Electrons occupying the energy shells in an atom take the form of a cloud surrounding the much smaller nucleus. Since only 2 electrons can fit into each of the energy shells, it is interesting to look at the characteristics of these different shells or energy states. These states are defined first by a primary quantum number called n, and also by a secondary quantum number called L. And for each state, the electron has a different energy, which results from the shape of the electron cloud. For n equals 1, called the ground state, the shape is a symmetric cloud, the same in all directions. For n equals 2, the shape can take 2 forms depending on the value of L. Although both shapes have the same energy, one shape is a double spherical cloud, one sphere inside the other, while the other shape for n equals 2 is in the shape of a dumbbell. For other values of n and L, the shapes can be pretty strange, like this torus plus dumbbell shape. An electron in the lowest energy shell in an atom can be struck by and absorb the energy of a photon, giving it enough energy to jump to the next energy shell. And the reverse process allows the electron to jump back down into the lowest energy shell and emit a photon. The color of the photon depends on the energy difference between the 2 shells. This explains the spectral lines that identify an element. Since white light contains all the colors in the spectrum, when we shine white light on a sample of an element under the right conditions, the atoms absorb all the photons that allow their electrons to jump to other energy shells. So, the absorption spectrum is all the colors in white light minus those that match the difference in energy shells within the atom. And when those electrons spontaneously jump back down to the lowest energy levels, that emission spectrum contains only the lines that match the difference in the energy shells within the atom. Here is a piece of spectra from hydrogen. The primary quantum number n is shown on the right alongside the line representing that energy level. When an electron jumps from the n equals 3 shell to the n equals 2 shell, red light is emitted. When an electron jumps from the n equals 4 shell to the n equals 2 shell, aqua light is emitted. When an electron jumps from the n equals 5 shell to the n equals 2 shell, blue light is emitted. When an electron jumps from the n equals 6 shell to the n equals 2 shell, violet light is emitted. When an electron jumps from the n equals 7 shell to the n equals 2 shell, ultraviolet light is emitted. No jumps to n equals 1 are shown because they are all in the deep ultraviolet.